Hello, I'm Gary Williams, and for this Tech Bite-sized talk, I thought it would be nice to talk about Dhcp. One of the reasons I picked Dhcp is my second favourite protocol of all time. I just think it's incredibly neat and elegant in how it works and how it does what it does. The one problem with the name Dhcp is it doesn't really tell you what it does. Dhcp stands for Dynamic Host Configuration Protocol, but it doesn't tell you what it actually does. What's a dynamic host? What does it configure? Alright, protocol tells you it's a protocol, but well, so is most things that go over TCP IP. So from that angle, you don't really get to learn very much about it just from its name. So let's see what Dhcp actually does, what it brings to the party, and why it's really, really handy. The device starts out with an IP address of 0000, and what it will do is it will do a broadcast out of the network card. So this broadcast is going to go out across your network, and what will happen is the Dhcp server will hear the broadcast, and that broadcast has a special frame in it that says, hey, I need an IP address. So the Dhcp server hears that request and it makes an offer, and it says, hey, I've got an IP address for you. Here is an IP address 192.168, whatever it is, and it makes that offer back to that machine. Now what it will do, because the machine doesn't have an IP address, it's doing all this using the machine's MAC address. Now if you know networks, you'll know that all this stuff is operating at layer 2. Layer 2 is MAC address, layer 3 is routing, so we've got no routing going on here. This is flat VLAN, this is simple VLAN, this is layer 2, this is not going over any routers at this point. So discovery, the offer goes back to the MAC address of the requesting machine. The device will take that IP address, it will apply it, and then it will send a request back to the Dhcp server saying, thank you, I have received that offer, I'm accepting it, I now have this IP address. The server will then update its table to say that IP address has that MAC address, and it will send an acknowledgement back saying, that's all good, I've got it, you can have that address for X amount of time, everything is good. And what you'll see is this takes place over a time axis. So discovery, offer, request, acknowledge should take 2 to 3 seconds, something like that. It should be so fast that the computer is actually still starting up in the background while all this is going on. Now if something goes wrong and your machine doesn't receive an IP address, it will default to an APIPA IP address. Or let me rephrase that, a lot of machines will default to an APIPA IP address. That's those 169 IP addresses you see. I think the IP address range is one of Microsoft's. They invented the whole APIPA protocol. But what it will do is it will do a 169 address. So one of the ways you can troubleshoot Dhcp is start command ipconfig, and you can have a look, and if you've got a 169 address, you know Dhcp hasn't worked. And in essence, that is pretty much all there is to Dhcp. It's just a mechanism for giving an IP address. Along with the IP address, it gives other information such as default gateway, such as DNS servers, and it can also give a few other bits and pieces. There's this whole thing in Dhcp called the list of options, and in those options you tell it what you want to give out. So that's it for Dhcp really, but this wouldn't be a very good video if I didn't actually show it in operation, would it? So why don't we jump across to a Windows Dhcp server, and I can show you how you install it and how you configure it. As I've RDP'd into my Active Directory domain controller, fired up Server Manager, and if I hit Add Roles and Features, hit Next, and Next, and Next through all the waffle, get rid of that banner there. You can see here the Dhcp server is already installed, and if you're installing this fresh for the first time on the server, you just tick that box. There's nothing else to it, it's under server roles, and then you just next through and it will install. No reboots required, it's just there, it just works. Let's jump across to Dhcp itself. Once it's installed, you must authorize it. Now authorization only happens on Active Directory servers. The idea behind this is that it stops other people from creating a Dhcp server role, because Dhcp is just a role that can be installed on any Windows server if you've got the necessary rights to install it. And what this authorization does is it stops people from making their servers Dhcp servers. So obviously you really don't want to have more than one Dhcp server serving a VLAN. You can have multiple Dhcp servers on a network, but they have to be serving individual networks, VLANs, however you want to cut it up. But what you don't want is you don't want two Dhcp servers on a single VLAN. If you do that, they're going to fight, and it's going to be the fastest responding server that wins. So what I've seen in the past, I've seen people say, oh, but I want my Wi-Fi to take DHCP IPs from that device and clients from that device. Guess what? The DHCP server doesn't know. It doesn't work that way. So one DHCP server per VLAN. The whole authorized, unauthorized thing for DHCP in Windows is a bit crap, to be honest, because there are many other DHCP servers out there that don't go through this. This is a pure Active Directory thing. If you want to block additional DHCP servers, the best place to do it is actually on the switch side of things. A lot of switches these days offer something called DHCP Guard, and what that will do is it will block any DHCP requests unless they're going to a specific port or a specific IP. All depends on the type of switch. That's really, really handy when you've got developers, because developers can go and install anything they want. You know, they can go and install a DHCP server on a Raspberry Pi or something like that. So DHCP Guard on the switch is a good way to protect your DHCP server and stop a rogue DHCP server from being put on your network. Also, bear in mind, a rogue DHCP server can be used to initiate an attack on your network. It can gather information, it can hijack machines and do all sorts of damage. So you've got to be quite careful with DHCP. It can cause a lot of damage if it's configured wrong. So this is DHCP on my server, and what you will see is I've got both a IPv4 and an IPv6 scope. I'm not going to dig too much into the IPv6 scope because I'm just experimenting with that at the moment, and most people are still using IPv4. If I expand out IPv4, you will see the scope is 10.253.1.0. Now the reason I have 10.253 is there aren't very many places that use the 10 range right up against that side of the scope. A lot of places will use 10.1, 10.2, things like that. Very few go up to 10.253. And what it means is from my network I can VPN into other networks and generally don't have an IP clash. So what you'll see is I picked 10.253.1.200 to 10.253.1.240 as my range for distribution. If I drop down into the address leases, this is everything that actually has a lease, and you can see the unique ID here. The unique ID is the device's MAC address. So if we take a look at this one here, that's a VMware VM. It's not got a name on it, so it's one I've just spun up. But you'll see here, you can always tell what's a VMware VM because the MAC address starts 0050. It's a nice way of finding out what a device is just by looking at the unique ID. If I go down into reservations, I don't actually have any reservations. I don't use reservations on this lab network. But what reservation is a way of reserving an IP address so that a device gets the same IP address every single time. This is used very commonly on printers because you want the printer to have the same IP address, and it's just a nice simple way of doing it. You reserve one of your IP addresses in the pool, job done. Scope options are really where a lot of the magic happens for DHCP. Your scope option is something that can be sent alongside the DHCP packet. So when the packet goes out, it's got the IP address in there, it's got the MAC address it's going to, but it can contain additional information. In my case, I push out the bare minimum. I push out the router IP address, I push out the IP of the DNS server, and I push out the domain name. The domain name is in there so that when I do a search for XYZ, it just tags this gdwnet.com on the end. There are hundreds of options. A lot of these options are actually now obsolete, things like time offset, log servers, cookie servers. A lot of these are obsolete. I don't know anywhere that uses these. Now, this is all really good for a flat network, one VLAN, something like that. But how does this work if you have multiple VLANs? What happens if you've got, say, 10 VLANs? Do you need 10 DHCP servers, or do you need a DHCP server with a network card on every single VLAN? There's a little trick included in the DHCP protocol called the Dhcp Relay or the IP helper, and I'll show you how that works. To demonstrate how this works, what I've got a small VM here, which I've consoled onto, and if you look at the bottom right, you'll notice no internet access. And if I do an IP config, I've got this 169 a PIPA address. This means that the server is broadcasting out, but it's not getting a response back, so it can't get an IP address. So let's get this server set up on DHCP. All I have to do, jump over to my DHCP server, give it a description. I like to give the names, I like to make the names the IP range that I'm using. I just find that easier to work with. So the start IP address, now these are just arbitrary numbers from that range. It's always worth documenting the IPs that you're using just to avoid an IP clash. So my subnet mask 255.255, what that does is that gives me a network of 10.251.1.0 to 2.254. In this case, of that 254, I'm further dividing it down and saying, hey, I only want 20 IP addresses given out. Well, actually it'll be 21 because 20 to here and then plus that one. Notice here we can add exclusions. Exclusions will go in for things that you have a DHCP IP address for, but you might want reserved. I don't want any exclusions. If you look at the lease durations in DHCP are really interesting. So by default, you get a lease of 8 days. You can change this to what you want. You can change this to 5 minutes if you want, but it's not recommended. Now, what happens is when your device gets an IP address, it will have that IP address for lease duration. Let's say 8 days. What it will do at 50% of lease duration, so in this case 4 days, is it will speak to the DHCP server direct. And the reason it does this is it knows the DHCP server's IP address, so it'll actually go to the DHCP server and say, hey, can I keep this IP address for lease duration, 8 days? The DHCP server will either say yes or no. There's no reason it shouldn't say no, it should always say yes. Renews the lease. Once the lease is renewed, again 4 days later, hey, can I keep the IP address? 4 days, hey, can I keep the IP? And so on and so forth. Now, what happens if you change the IP address to the DHCP server? Well, halfway through the lease duration, it goes to the IP address, and if that server isn't there, it's not going to get a response. So it will keep the IP address because it's still got 50% of the lease time left, and it will try renewing again at 99%. It tries again at 99.5, 99.7 I think it is, 99.9, and then the lease runs out. And once the lease runs out, it drops the IP address. At this point, it's got no IP address, so it broadcasts out for a DHCP server and says, hey, give me an IP address. If the DHCP server's IP is changed, at this point, the server will hear that DHCP request because it's a broadcast, gives the server IP address, everything works. This is a really good way to change DHCP server's IP addresses. You just let the leases expire, let it give out new IP addresses, and you're all good. Problem is, what happens if you don't have a DHCP server? Well, what will happen is the IP address lease time runs out, it broadcasts out, it gets no response. Eventually, it goes back to the PIPA IP address. It's one of the reasons I like the protocol. It's very clever in letting you change IP addresses without too much worrying in the ways of consequences. So what I'll do, I'll actually set this lease time just to a day. I don't need anything longer than that, so that means at 12 hours it will try and do a lease renew. So yes, always configure the DHCP options. So we've got the router or default gateway. On my network, if I can type properly, it's always at the far end, the 254 end. So we put that in. The parent domain is fine, and I want 10.253.1.44 as the DNS server. So it's going to have to go across the network for DNS. That's all fine. Win servers, I don't think anyone uses Wins these days. Wins is a holdover from Windows NT. Avoid them. No, I don't want to activate the scope. The reason I don't want to activate the scope is I just want to show you what an unactivated scope looks like. And you'll see you've got this little, not quite red cross, but red down arrow thing there. It's a bit hard to see, but that means that scope is there, but it's not activated. So if I activate, what that will do is it will authorize it, and it will now say to Active Directory, hey, this is all good. This scope is now active, and it's waiting for requests to come in on that. Now, before I do anything, let me just jump into a command prompt here. You'll notice my server is 10.253.1.44. I don't have an IP on this range. If I jump back over here and ignore the Windows updates and do IP config renew, that's going out, it's doing a DHCP broadcast. Now, it's not going to get a response. I've set up my scope, but because this is on the 251 network and the network use /24, it cannot speak to this server here. It cannot get to it at all. I should really say this server here, shouldn't I? It cannot get to it at all. It can't see it. This server will not hear that broadcast. So that means we need something in the way. We need something to intercept that broadcast, and that's your Dhcp relay, sometimes called an IP helper. The reason it's called an IP helper is that Cisco terminology. When you're configuring Cisco at the command line, the line you use to enable a Dhcp relay is IP helper. And as you can see, it's taken a little bit of time, but it's come back and gone, hey, there's an error. Can't say it. Can't find an IP address. IP config, I have my pipper. There you go, my 169 address. So that means my server cannot talk to my Dhcp server. So what I have to do is I have to jump back to here. You'll see one of the options in here is Dhcp Relay. The reason I like pfSense to act as my firewall and router is just it's graphical, it's nice and easy. I'm lazy, can't be bothered with command line. So I want to enable Dhcp Relay on the UAT interface, and I want to give it a destination server 10.253.1.44. So the reason for giving it that IP address is because that's the IP address of my Dhcp server, and the interface it needs to listen on is the UAT interface. So what will happen is the server will broadcast out, the firewall will hear that broadcast and go, hey, I'm a Dhcp server, which it isn't, but it will cheat and it will say, I'm a Dhcp server, forward the request on and say, hey dude, can you give me an IP address for this VLAN? Dhcp says, yeah, I know about that VLAN because I have it configured here. Hands out an IP address, passes it back to the firewall hands it back to the client. At that point, the firewall's job is done and the client can talk direct to the Dhcp server. So it doesn't overload the firewall that much. It's a little bit of extra traffic, but it's so minor. Yeah, it's not going to matter. So that's now enabled, changes successfully applied. I jump back to my server, IP config, renew, ask, and you'll see here the lease was obtained on the 28th of October at 13:49:58, goes down to the second, and it will expire exactly 1 day later. Now if I decide in the future I want to change the lease time, it's very easy, just do properties of the scope. We come down here and we could say have 2 days. Now I don't have to change anything, I just wait. When people renew, they'll get the new lease time. So if I come out of this, do an IP config renew, wait a few seconds, IP config or more, you'll see now all of a sudden lease obtained here and it goes through till there. You'll notice the time is slightly different, it's not exactly 1 day, and that is because the lease got renewed. It was obtained at this time, so it's actually gained a few minutes because I did renew much earlier than I would normally. Now if you've got a machine that's on for months and months and months, the lease obtained will be the moment that server was turned on and it got the lease. So that does mean that you could have a Dhcp lease time of 1 day, but it could obtain the lease months and months before the current date. That's perfectly normal. That's when you got the lease. You can keep on renewing that lease time and time again. And you'll see here I've got my default gateway, I've got my Dhcp server, everything is good. Just to prove everything works, ping good old 8888. The reason I always choose 8888 is I know it responds to ping. And always ping an IP address because that leaves out DNS. It's a nice simple, effectively low layer way of testing things out. And then you can test out DNS like that. That tells me that my Dhcp is working, that tells me that my IP name resolution is working and everything is good, and this server is now ready for use. Now, a lot of places, if you're using a server, you're not going to use Dhcp, you'll actually use static IP addresses. Some places will use reserved, doesn't really matter. For demonstration, this just sort of shows you how it works across VLANs and how you can have a server, which is your Dhcp server sitting on one IP address but serving IP ranges for many others. I hope you've enjoyed the video. That's really everything I've got to say about Dhcp. I'm hoping it's given you a pretty decent overview of how it works. There's there's a few bits more to it. There's things like Pixie boots and stuff like that, which I won't go into. I might cover that when I do a video on WDS. But this should give you a pretty thorough understanding of DHCP, how it works, how to install it. Obviously, I've stuck more with Windows here. You could do this on Linux. You could do this on a Raspberry Pi if you wanted. Doesn't really matter. There's other services out there that will give you DHCP. There's quite a few applications on the internet that go off and do DHCP. Some Wi-Fi kit has their own DHCP servers built in and so on and so forth. But that just gives you a grounding on the protocol itself. So in conclusion, the only other thing I've got to say is thank you for your time, and if you do have any comments, please put them below. Please do like or dislike, comment, subscribe if you found it handy. I will be doing a few more in-depth videos and some more tech bite type videos. Again, anything you want to see, any comments, stuff down below, please. It really does help.